Hello class, welcome to Big Bang Data Science Solution Ramadan program. And now we are in the last week, or week number 8, and it has 2 sessions. So in last week we talked about an introduction to machine learning, and we covered the basics about the decision tree. And today we'll talk about we are going to build a decision tree algorithm using Python. So that is the plan. And tomorrow we are going to finish probably by adding another algorithm. And for those who are interested, in the certificate, so they have to pay for it, and we will offer them. We are going to offer them a real project, capstone project, which should be 1 month. And of course, you are going to get the support, and also you are going to get the the evaluation of your work. So reach out to me in private if you are interested in the project. So let's assume that we have this data here. Now we have a data about our students, and you've been hired as data scientist, and you are working for a school or university, and you want to predict ahead of time if any student will graduate towards the end of a semester or the end of a program. So we collected some information. So we got the student ID, student name, their age, their marital status, they're married, divorced, widowed, unknown. And we have here hours spent. So we got how many hours they've been studying, and of course we got the target variable, or this is what we're trying to predict. 0 means they did not graduate. 1 means graduated. So graduated, did. And so this is a historical data. And we want, once we learn a model, once we learn a parameter, once we learn the function, to map the inputs with the target variable. Of course, we want to try to predict if a student 20 and 21 will graduate or won't graduate. And we are going to use this data here. We are going to use machine learning algorithm decision tree to build, to determine or to make such prediction. So the way this decision tree works, as we talked about the last week, is number one. We for any machine learning, especially if we are using scikit-learn, few things need to happen. So number one is we need to identify x and y. So we need to tell the model this is the x and this is the y. Number 2, we need to split the data set into at least 2 partitions or 2 parts. The first one should be larger than the second one, 80% and 20%. You could do 70 at 30, 75, 25. It doesn't really matter as far as you have one partition larger than the other one. Then number 3, sometimes you might need to scale your data, especially if you are using depends on the model you are using. For the decision tree that we are going to use today, you really don't need to scale because decision tree does not care that much about the value of the attributes. So, but scaling is required if you are using probabilistic and algebraic models. After that, then we are going to use the algorithm. In our case, it's going to be a decision tree. And few things. So how do we use this algorithm? It could be decision tree, it could be naive Bayes, it could be support vector machine, it could be regression models, it could be any model. So number one, we need to train the model or this algorithm model on the 80%. And using a method called fit. And when it's a method, so it does require some parameters, and we need to fit x comma y. And after we fit the model, means train the model, the second step in the process is we need to test the model on the 20% using a method called predict. And when we predict, again, as a method, as a function, it requires some parameters. We need to pass only x. And finally, so this predict method will generate predict method will generate a new column called predicted target variable. Okay, and now what we have to do is we need to compare the actual target variable with or to the predicted target variable. Number 5, then optimize if needed. So this is the plan that we are going to do to build the first algorithm, which is decision tree. So any question concerned about this, please speak up. Any question concerned about this? So for this small example, we are gonna split randomly. It's a random split. Let's assume this is the random split. Okay, so this is our this one is our the first part is going to be our 80%, and the second part is our 20%. So in 80%, we got x. This is all x's. and we got the y. So all x's are the inputs. The y is the target variable that we're trying to predict. So we are going to do the fit. So we are going to do fit x comma y. So we are going to learn from x and y. But when we test, we are going to ignore the target variable. So when we test, we are going to test only, or using the predict function. And on x, only on x. So we are going to hide. We are going to hide this target variable from the predict function. And this predict function, what it does, it is going to create a column. It's going to create a column that is called predicted target variable. It's called predicted target variable. And this column would have zeros and ones. 1 and 0, for example. Then we are going to compare. This is called predicted target variable, and this one is called actual target variable. Why it's actual? Because we have it. We already have it in the data. And now we are going to compare. We are going to compare the predicted target variable that was generated by testing the model that we learned in 80%, testing on the 20%. So we're comparing that predicted target variable with the actual target variable and see how closer they are. The more closer they are, the better the model that we learned at 80% is. The more dissimilar or they are distance-wise are, the worse the model that we predicted or that we built is. So that is the plan of every single model that you'll end up using in the future, especially if you are using supervised learning, where you have a target variable, and that target variable could be binary, trinary, multi-class, and nominal. That in this case it's a classification problem, or it could be a value. And in this case, it is a regression problem. So, question, concern. Any question, any concern, any doubt about this process?
Hey Mo, just a quick question. I mean, I know we follow all those steps. The one step that you didn't mention is the scale your data. So we want to like remove maybe marital status when we are scaling the data.
That is not scaling. So removing marital status is transforming the categorical into numeric. So we have to do, so number one, we are going to do some selection now using many methods that we learned. So we know for sure we are not going to use SID. We are not going to use the name, because these two features here wouldn't actually add any value to the analysis. This is simply too much personal information, and this one is simply it's a random number that wouldn't add any value. So we got age is numeric. We got hour spent is numeric, which is good, and target variable is binary. The only one thing for this specific example is transforming the marital status. If we decide to use it, is transforming it into categorical into numerical data. Scaling is totally different. Scaling is simply putting all your data within a smaller range. It could be between -1 and 1. It could be between minus 3 and 3. If you were to use this score, it could be between 0 and 1. Why do we need to scale? Why do we need to put all the data in the same range? Is because an algorithm in general is simply a mathematical function that handles or deals with numbers. So it considers, in theory, it considers any large values better or important than small values. So to avoid, if you don't scale your data, your model will be biased towards larger values. So 60 is better than 33. 33 is better than 19. 45 is better than 19. So of course we don't want that to happen. So what we have to do is we need to scale age and our speeds. We need to put them all between -1 and 1, or -3 and 3, or 0 and 1. In that, so if we scale, the model algorithm is going to treat every single attribute with the same level of importance. Otherwise, the large values will dominate over the small values, and of course, that is a biasing. Yeah, I mean, the model that you'll be creating would be biased towards large numbers. Okay, Amir?
Yep, sure. Yeah,
Good.
thanks for yeah.
You're welcome. Any other questions, concerns about this? Questions, concerns, please speak up. Okay, so now, so this is the process of building a model for classification and and it does apply for regression also. For clustering, it's totally different process. So now, how algorithms, interact with the data. So every algorithm has a different method of interacting the data. And last week we started with decision tree, and we are going to continue explaining the process of decision tree. So this is the process of applying machine learning to data. But every machine learning behaves differently, and we are going to talk about how this decision tree behaves. Okay, so a decision tree is an upside down tree. It simply uses the F rules. But the way this decision tree works is, number one, it depends on what are you trying to learn. It simply depends. We call it objective function. Is what are you trying to minimize or maximize? There are many methods that decision tree can use. Decision tree can use many methods. One of them is entropy. Second, Gini index. Third, classification error. And of course, there are fourth and fifth, etc. So of course, we are not going to use all of this. We are going to use the entropy. So decision tree, number one, treats decision tree treats all features with the same importance. So it does use a process called IASM. Treats age the same way she treats MS, the same way it treats the our spans. So in other words, it is going to split. It is going to split So decision tree, as I said, treats all the features with an equal importance. So it is going to split on names, on its ID, on age, on marital status, on hours spent, etc. And this target variable is untouched. But of course, we know we are not going to use the names, and we are not going to use the SID. So before decision tree splits, the first thing it does is calculates the entropy, calculates the entropy of the entire data set. And so that is what it does. And the formula used to calculate the entropy is minus the probability of a zero, okay, multiplied by log of probability of zero minus probability of 1 multiplied by log base 2 of probability of 1. So it does calculate the entropy of the entire data set. The entire data set means everything. Then it splits on all features. Yeah, splits in all features. On all features and calculate entropy of the feature, all the splits, all splits. Okay, and it's going to split split an age, and it's going to calculate the entropy of age. It's going to split an age simply by it is going to use the mean. If we have if the feature is numeric, it's going to split on the mean. So probably the mean should be 40. So it's going to split on greater than 40 and less less than 40, and it's going to split. And if it's numeric, if it's non-numeric, or if it's categorical or nominal, it is going to split on on the frequency and the mode. So let's say that you got M, so it's going to split on M or not M. And our spent, it is going to be split, of course, on the mean. So so for each split, we have right, left side, right side, left side, right side, left side, right side. This is what is happening behind the scene. We are not going to do this manually. Is the system does it for us. But it's always good to understand what is exactly happening behind the scene. So we split, and we calculate the entropy for our split. So we are going to calculate the entropy.
Mo, can I ask a question?
Yes, sir.
So the entropy is calculating this split based on the actual number or based on the scaling numbers? Do we have to give they
I mean,
provide.
again, I just mentioned this in the decision tree. We don't scale.
Okay. Okay.
We do not scale for decision tree because decision tree is not probabilistic model. It's not an algebraic model. Good
Okay.
question, but it does not require scaling. So it is going to scale. Is going to split on the actual values of a feature.
Okay, so there are different methods in machine learning. There we need to scale. So we need to understand which model we are using. Accordingly, we have to
Yes,
fit
sir.
the data.
Yes.
Okay.
So for every model, once and this comes with experience, comes with studies, comes with the efforts that
Okay.
you'll be put in the future. So for every model, you need to know the how these models are working. You need to know the type of the models. Are they numeric, non-numeric, algebraic, non-algebraic, probabilistic, non-probabilistic? Are they deterministic or holistic? Are they parametric, non-parametric? There's a lot of type that you need to know, and also you need to know their assumptions. You need to know the pros and cons, the speed, etc. That is how you determine which model to start with.
Okay.
And
So I have another question for entropy. So when you are saying mean, right? So does the formula itself calculates the mean, or do we have this is
no,
mean when we
just
are?
tell it. Just tell it. Please use the entropy, and it
Okay.
knows what to do.
Okay. I get it.
So you
Thank you.
need to determine. You need to tell it what is the method you want the decision tree to use. If you want the decision tree to use the entropy, this is what is happening behind the scene.
Okay.
If you
Okay.
want to use the Gini index, there is a different calculation. If you want it to use classification error, other method, totally different calculation. So now I'm doing this with assumption that you are telling it to use the entropy.
Okay.
And in the codes, so this is the codes, you are telling, and we will go through this. So this is where we start building the decision tree. Okay, we are building decision tree here, and you are telling it, yeah. So we import the algorithm from the scikit-learn, and now we initiate the algorithm, and you are telling it, please use the entropy as criteria. You could tell it use, I believe, Gini, and it is going to simply use different calculations behind the scene, which I really don't care because I'm not, all I'm interested is learning about the output. How it does it, I really don't care. But yes, it is my responsibility to know how it works and be able to explain it to the managements if, just in case they ask about it.
Okay. Thank you.
Okay, you're welcome. Okay, so we are assuming that we are telling it we are using the entropy criteria. So this is what entropy does. And Gini index, it does the same process but different calculations, different mathematical function. The entropy use the minus probability of 0 multiplied by the log 2 of probability of 0 minus probability of 1 multiplied by log 2 of probability of 1. Okay, so step number 1, treat is going to treat every features with the same importance. Step number 2, calculate the entropy of the entire data set. Step number 3, splits every uses all the features to split, and only one split and stop, one split and stop, one split and stop. It does not continue. After one split for all features, and now it is going to calculate the entropy. Number 4 is going to calculate the entropy of left hand side plus right hand side of all splits. Okay, can anyone explain what this is supposed to mean? What is what this means? What does this mean? Anyone?
So basically, it will like for example, for age, we have greater than 40 and less than 40 is going to do the first the set of less than 40, do the function on that, and then do the same thing for the other set, like the right side of age.
Yeah, let's
Separately.
talk about the age. Let's explain this and in terms of age, how this is going to work. Entropy of left hand side plus the entropy of right hand side.
I think it's going to swap the P0 and P1 for less than 40 and greater than 40, making perhaps less than 40 probability 0 and then greater than 40 probability 1. In another point, do it the other way around and then adding it together.
Thank you. So when we split the data, of course, we are going to get few values in the right hand side, left hand side, and right hand side. So values, we are going to get some zeros and some ones. And values of the right hand side, we are going to get some values with the zeros and some values with the one. And now we are going to use this formula here on the left hand side, and we are going to use it again on the right hand side. We are going to do the plus, and we are going to do the same on MS and the same on our span. So entropy of left hand side and right hand side of all splits. We got 3 splits. We got 1, 2, and 3. So it is going to calculate the entropy of age by calculating its left hand side plus right hand side. Then it's going to calculate the entropy of MS by calculating the entropy of left hand side plus the entropy of right hand side. Then it's going to calculate the entropy of our spans by calculating the entropy of left hand side and right hand side. And step number 5, it is going to subtract the original entropy from the features or split entropies. Splits entropies. Okay, let's assume that the entropy from the entire data set is, let's say that it's 0.7. And by the way, the entropy here is simply means how uncertain you are. So we have 70% uncertain if we were to determine if student 20 and 21 will graduate. We are 70% uncertain to determine that. And the lower, the more this entropy value, the closer the entropy value to 0, the better. So, and we are going to calculate the entropy of age. So let's say that, so this is number 1, overall, or the entire data set, entire entropy is 0.7. Age is, let's say, 0.5. MS is 0.1. Our span is 0.3. So we are going to subtract 0.5 from 0.7, 0.1 from 0.7, 0.3 from 0.7, and you got x2, x3, x4, xn. It depends on how many features that you have. Okay, so let's assume this is our value. So 0.5, 0.7 minus 0.5 is equal what?
0.2.
0.2. 0.7 minus 0.1 is what?
0.6.
0.7 minus 0.3,
0.4.
0.4.
0.4.
So which one is closer to 0?
0.2. Age.
So it is gonna keep, so it splits on 3, but it's gonna keep the lowest entropy. Okay, so now we are gonna get the first splitter is gonna be age. Is gonna be this, the first splitter. And the other ones, they are be ignored. This is gone. And this is gone. So now it splits on age. So so we got we split an age, and now we are going to repeat number 6, and we are going to repeat the process from 3, 4, and 5. For left hand side and right hand side of the chosen splitter. So what is the chosen splitter here for in this case?
Age.
So yes, now it's split on age, and we got some values. Let's say that we got 6 million records when we split on, and we got 3 million records greater than 40, and we got 3 million records below than 40. So, and in this 3 million, of course, we got zeros and ones. We got graduated students and failed students, and the same for the students below 40. So now we are going to split again. We are going to take this left-hand side and split it on age, marital status, and hour spent. And we are going to take this one also, and we are going to split it on what? Can you tell me?
Same thing.
Yes, sir. Thank you for following. Age, marital status, and hour spent. So we already have, yeah.
Brother Mo, age is already finalized in the splitter, so we need to take age again.
Yes, it does it again. All of the features. So what do we have about the age? We already have the entropy, right? So the entropy is the entropy of the age is the entropy of its left-hand side plus the entropy of the right-hand side. So now, when we split on age, we are going to get something like this. Okay, and we are going to calculate the entropy of left-hand side and the entropy of the right-hand side. So we are going to calculate the entropy of left-hand side age, left-hand side MS, left-hand side hour spent, right-hand side age, MS, and etc. So let's assume that the MS is the winner, and let's assume that for the left-hand side, and MS, or the hour spent is the winner of the right-hand side. So the split is going to look like this. The first split on age, 40, and the second for the left hand side is going to be split in each hour, hour spent, hour spent, and the second one is going to be split on marital status, and we are going to repeat again. We are going to repeat for left hand side. We are going to split this also, split this, and split this. So every split has a left hand side and right hand side. Then we'll keep repeating 3 and 4 and 5 until one of the conditions happens. Until when do we stop? We stop when do we stop? When we reach purity. And I will explain that when we reach a threshold. Time constraint. Constraint. No more data. There are others. Okay, so we reach purity means when we split every split. So every split, of course, when we split, we are going to have a zeros and ones. And if you split and you have only a 0 or a 1, then you stop. Means now we reach the purity. Purity, sorry. Yeah, it's a typo. Yeah, time constraint. So please excuse my typos. So so we stop when we reach a purity, means that we have only one class in the split, or we stop when we reach a time. You tell it to run now, just run for 20 minutes. We split when we reach a threshold. We say, okay, I want to stop in split number 5, and we split when there is no more data. So it's going to keep splitting all the way to the end. And of course, some of these methods to stop it are better than the other ones. If you let it learn all the way to the end, your the decision tree will end up learning the position of the data rather than learning the patterns out of the data. Okay, so any question, concerns about how decision tree works?
So Mo, I have a couple questions. So sure. I know the step 3, 4, like 4, 5, 6, we are repeating, right? So let's say if we go to the second level, like when we are from, when we are doing the subtraction, is again the subtraction from the entire data set, or subtraction from the age, from the second level?
No, the second level is from age.
From age, not from the entire data set, no. From the age. Okay.
Entire data set is done. We are done with that.
Okay, so only the first level will do the entire data set. The second level is whatever the top level is.
Yes, sir. Yes, sir. That's true.
Okay.
But it's the same process. Let's say the age was the winner, then we are going to use the entropy of the age to determine which split is the winner.
Okay, got it.
We keep doing that all the way to the end.
And when you say threshold, do we set the threshold somewhere like a depth level or something?
Yes, sir. Yes, sir.
Okay.
Okay. Right. So any question, concern before we move on to the codes?
So Mo, just to clarify, when you said in the first step, calculate the entropy of the entire data set, you meant the 80% of the data set, not the 100% of the data set, correct?
Yeah, I'm talking about 80%. Yes, sir.
Okay. All right.
Thank you for Korea. Thank you for bringing that up. Yes, 80%.
Okay.
Okay. Yes. entire 80%, entire 80%, which is in our case this is the entire data set, not everything. It's simply when we split, we lose almost 20%. So we are going to split. We are going to calculate the entropy of 80%. Okay, folks. Other questions, concerns? Everybody, please speak up before we move on to the codes. Okay.
Would that be possible through the code to see these steps?
Yes,
Because
sir.
I honestly, I'm still not clear about what data is changing every time when you splitting it again and again.
Yes, sir. Yeah, we are going to do that. Yes, we are going
Okay.
to. But do you have what is not clear?
Because I'm not sure when you do the second time split, what changes in the data that it's going to give you different numbers for step 2, 3, and 4.
So let's assume that. Okay, let's do it one more time so you can understand. Okay, let's assume that in the data that we have, actually, let me copy this one more time. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's assume this is 80%. And we got 10 records. In these 10 records, can you tell me how many zeros that we have and how many ones that we have?
3, 4, 5, 6, 7, 7 zeros and 3 ones.
Okay. And when it's in the, so we understand step number 1 and step number 2. And now step number 3 is gonna split on age. It's gonna split on MS. It's gonna split on hour spent. Right?
Yeah.
Okay, so let's for the age, because it's numeric, it is gonna split on what?
The mean.
So let's assume the mean is 40. Can you do the math for me, please?
Yeah, less than 40 would be 1, 2, 3, 4, 5. There are 5 and total are 10.
Okay, for the first 5, how many zeros do we have?
5. 4.
Okay, so, I mean, I'm not reading. 4 zeros and 1, 1. So we got here 4, 6, 7. So then we are going to have 2 zeros here and 4 of ones, right?
Yeah.
Okay, so let's assume that now the age is the winner. And now, so the entropy of age is 0.2. So the entropy, sorry, the entropy, the entropy of left-hand side and right-hand side was 0.5. And when we subtract it from 0.7, we got 0.2.
Yep.
Clear about that?
Yes.
Okay, and now let's take a look into this part in here. Okay, so we got age, left hand side, and we got age, right hand side. Okay, and now we are going to split on age. Yeah, we are going to split. It is going to split on age again. It's going to split on multi-status. And it is going to split on hour spent.
Also, so now it's going to split on the remaining of the age and then take the mean of that.
Yeah, so now we have 5 features. So for the yeah, for for the left hand side, we are going to get this animal, this one, and we are going to get this one, and this one. Got 1, 2, 3, 4, 5.
I got
So
it now. I got it. Yeah.
yeah, yeah, just let's let me do this. So this is what we have here for the left hand side. Okay, and for the right hand side is the opposite. Okay, and let's assume. Are you guys clear at this point of time?
Yes.
Yeah. Yeah. It's
Any
clear.
confusion, any concern about at this point of time, please? John, Jasmine, Idris, Hisham. There are a lot of folks in here. Are you guys clear about this?
Yes.
Yes, sir.
Thank
Yes, clear.
So now, assume that let's assume that the winner is MS. So it's going to split on the MS, and of course we are going to have here. We are going to have MS is single because we have 2, and non-single. How many singles do we have?
2.
So we got 2, and then we got 3 here. 2 plus 3 plus 2 is 5. So how many for the single? How many zeros do we have?
2.
2 zeros, and how many ones do we have?
0.
So how many classes we have here? How many classes we have here?
One class. You can't go further.
Now I'm talking about this one. This one, how many classes?
2.
We got classes of 0 and classes of 1. So is this pure or not pure?
Oh, it's pure.
No, sir, it's not pure because we have 2 classes. Pure means 1 class.
Okay.
So the entropy here is higher than 0 because you cannot tell if it's 1 or 0. But for this one, how many classes do we have?
1.
So it's pure.
Classes of 0.
And the entropy is going to be what?
100%. 0%.
Yeah, 0%. Thank you, sir. Means I can tell, if it's 0. For the 3, for the other one is 3. So how many 3 that we have? So we got 1. So how many zeros? So we got 1,
2 zeros.
2 zeros,
1, 1.
and 1, 1. Is this pure or not pure?
It's not pure.
Then what do we need? We need to split this again. On what? We need to split on age, marital status, and the hour spent. and we keep doing it. For this one, we are done. We are not going to split any further. Why? Because we have reached the purity. And we are going to do the same thing for the right-hand side. We are going to keep splitting until we don't have any more data to split, or until we reach the purity of a node, or until we reach the node. We reach a threshold. Okay? All good? Can we proceed, please?
Sorry,
So one
Brother
question-
Mohden, what is the difference between purity and no more data then? It is same thing almost?
No more data means let's go with the right and the left hand side until we reach no more data. So what do we have here? So now we are going to split. When we split the second time, we are going to take out all the single.
No, my question is when no more data, then those also will reach to purity, right?
No, yes, but it's a
Different,
long
more steps.
It's a
long way to go. Yeah.
Okay, so now for the left hand side, for this left hand side, how many features do we have left? 3. I'm sorry, records 3. And now let's assume that the hour spent is the winner. So now we are going to split on our spent. And what is the mean? Let's say 45. Sorry, let's say yes, 45.
49.
Yeah, I mean let's say 49.
49.
Greater than or less than 49. Okay, how many features do we have now greater than 49? 1.
1.
And how many? Yeah, so and we got 1. We got 0 of zeros, and we got 1. And how many features that we have left? How many records that we have left? 2. How many for the 2? How many zeros that we have?
1 0 0 1. One of zeros.
Yes, you got 1 0 and 1 1. So this is pure. No more split. This one we need to
zero of the ones, no?
Now we got this is 0 and this 1 0 and 1 1.
Okay.
And this one we are going to split further down. And finally we are going to get 1 here and 0 here. So this is done. This is no more data. No more data. It's closer to the purity, but the purity is more accurate than going all the way to the end. Because if you let it go all the way to the end, you might end up memorizing the data rather than learning from the data. So it's called, it's a terminology used, it's called overfitting. That is a terminology used in this case.
And would we define the depth, similar we can define purity also, purity level. Which purity level we have to go or no?
There is a lot of parameters you can determine.
Okay.
One of them is the depth. Okay. So I assume that you guys have access to the codes. So this is the codes preloaded. So the first thing you gotta do here is number 1, import the packages we are gonna use: NumPy, Matplotlib, Pandas. Okay. And we are gonna import set the maximum values for the columns. And now we are gonna import the data. And in our data we got 51 features. We got actually 1 feature added. This is the index, so we are going to remove it. And the remaining, we got 51 feature, and we got 41,188 records. Okay, and let's take a look in the target variable. And for the target variable, we got 88%, 89%, it's a 0. and 80 in 12% is or 11% is 1. And if you were to guess, let's say that we have Jasmine, or we have Idris, just joined the business as a client. And if we were to guess the probability of him purchasing a term deposit, what would be our guessing using the historical data set?
He will not purchase. 88%.
It's going to be 88% zero. So that is guessing. But of course, we hired you as a data scientist, as an expert who can build a model that beats the 88%. So this is called the dummy model or baseline model. So any model that we are going to create in the future has to be compared with the guessing. If it's higher than guessing, then we are going to use it. Otherwise, there is no need to build to implement a model into production, because it did not beat, or they did not beat the guessing. So to do the guessing, all we have to do, so number one, we need to identify X and Y. So the X is every features except the target variable. Every features, all these features in here. So we are going to use all features. All features except the target variable. That is X. And the Y is only the target variable. So that is a requirement. So you have to identify X and Y. That is what we did here. So we identified X and Y. Okay, and now we are going to split the X and Y into 20% and 80%. Okay. So we are going to split into 80% and 20%. And the 80%, for the 80%, we are going to have, for our 80%, we are going to have X and Y, and 20% we have X and Y also. After splitting, and now we are going to build the dummy model or dummy classifier. So we are going to import from the scikit-learn so this is the package, and we talked about this last weekend. Of course, we cannot import the entire package because it's huge. So we are simply going to import whatever we need. So from the modeling, we are going to import the dummy classifier, and we are going to randomly we are going to make a guess based on the most frequent. So if we were to guess if Idris will purchase a term deposit using what is the most frequent?
Zeros.
Is the zeros. So
Zeros.
if we were to guess if Idris will purchase the term frequent using the most frequent, of course,
No.
it is going to be 88, and that is what we have here. It's 88. So that is guessing. And now we want to import. We are going to import a decision tree from scikit-learn. Import decision tree. Okay, and let's assume that we are not going to do this. We are going to use only one parameter. So
Hey Mo, I have a question.
Yes, sir.
So from that statement, from scikit-learn.tree, so what I'm telling here is don't give me the whole package, but from that package only give me that method, right?
Yes, sir.
Okay.
Yes, that is what it. Well, yeah. If you were to import the entire data, the entire package, of course, it's going to take a while, and I don't think any system can handle it. As far as I know, my system cannot handle it. So from the scikit-learn and you specify the tree, I need only a decision tree model, a method. And we are going to use this method here with an entropy. So we are telling it, hey, decision tree, go ahead and use the entropy criterion. In other words, you are telling it you need to calculate the entire, you need to calculate the entropy. Yeah, you need to calculate the entropy of the entire 80% and split and calculate the split, the entropy of the splits, and subtract that from the original, entropy, and pick the one, the best splitter, and continue until the end. This is all what you are telling it. So it does this behind the scene by simply getting it to use the entropy. And whatever the model here that we just initiated using one parameter, we are going to store it. We are going to save it in an object called decision tree in decision tree model. You could call it whatever you want. You could call it DTM. And now let's take a look into what is in this DTM. Okay. So these are all the parameters available for this decision tree. This method here comes with all these parameters. Okay, it has class weight none, criterion is entropy, max date is none, max features is none. This is all default parameters. Okay, so and these are the parameters we are gonna change later if we were to improve its quality. So what we just did here is we imported the method and we initiated the method with one parameter change or with the default parameters, and we stored the initiated model into an object called DTM. Clear? Yes, no, maybe?
Yes. Yes. Yes.
Thank you, sir.
So Mo, if I did not specify the criterion to be equal the entropy, like normally the criterion also will be none.
So if you don't specify the criterion, it is going to pick the entropy as the default. It has to have a criterion, and by default it's an entropy. If you want to change it to Gini index, you can. In other criterion, you can.
Okay, so the default is entropy.
Yes, sir. Let's take a look into the parameters. Decision tree. Here we go. Criterion. There are Gini index and entropy. Default. Actually, the default is Gini. Sorry. Okay. Splitter, base, random. The default is best. Max date is an integer. The default is none. Max sample split. So all these parameters, and they are default, and you could change them. So the default for the decision tree, if you don't specify anything, it is gonna assume that you are. Yeah, here we go. It's Jenny. I did not specify. It says Jenny. You see that?
Yes.
Okay. Now we want to since we learned entropy, we are going to override the default parameter for the criterion to entropy, and simply we are telling it learn or calculate the entropy using minus probability of 0 multiplied by the log base 2 of the probability of 0 minus the probability of 1 multiplied by the log base 2 of probability of 1. Then split and calculate the entropies of the split and subtract the entropy of the split from the original split, and keep only one feature, which is the best splitter, and repeat until the end. This is all what you are telling it. Okay, and now we are going to use what is in this DM. Can anyone tell me what do we have stored in this DTM?
The final decision tree.
Is the skeleton only.
Yes.
It's the frame with what is the parameter change that we did.
I mean, just change the name of the. Oh, you mean the parameter is entropy? So it's
We change only the entropy. Everything else is default. Okay, and of course we might need to tweak these defaults later if we want to improve the quality of this decision tree model. So DTM is the decision tree algorithm with the entropy as the criterion. That's it. And we are going to use that DTM to fit. Can anyone explain this line to me? DTM.fit.
So this is the training. This is we're gonna train our
train what?
Model.
80%.
80%, whatever. 80% of the data we're gonna use it for.
Yes, sir. What do we have in 80%?
Training set. X.
So
X and Y.
X and Y.
X and Y.
And Y. Yeah. Thank you. So let's fit. We learned something now, and it's 378 millisecond. That is the speed. It's very fast. So we learned something. What's next?
Test.
We're gonna test it on the 20% X.
So we are gonna test DTM. And can anyone explain this to me? This line.
So this is
only using the Y.
Why?
Yeah, we're getting the Y, like target variable. We are doing we're testing 20% of like passing the X of the 20% set and getting the target variable.
What happened? What happened with the this is this X or Y?
This is X.
What happened with the Y?
So the Y we will do the comparison later.
We did not do test comma test features comma test target, because we want to compare. We are hiding the Y from the model of the 20%, because that is what we're trying to compare it to. Okay, any question, concern about this? Any question, concern about this, please? Yeah, please speak up. Just say something. Those who have not spoken yet.
Yeah. So more one question. So DT underscore the Fred, that will have the value of Y, right?
Predict. Yeah. So this prediction will be stored on this object. This is simply an object. You can name it whatever you want.
Okay. Yeah.
We're gonna compare Y with this. No, it's not a Y. We're gonna compare Y with this in the
yes. So what do you think? What do you think will be stored in this DT underscore pred?
It's predicted Y.
Predicted
variable. Predictive variable.
Predicted Y, and we are to compare it with
the
actual Y. That is the plan. So any questions, any concern about this? Those who have not spoken yet, please speak up. Or I'm gonna be forced to call names. Joy, Khalidi, Javid, Nadim, Monir, Muhammad, many Muhammads here. Osman, Shadab, Yusuf, please speak up.
No, I'm good with this.
Thank you, guys. I really, I love to have an interactive class. I'm the kind of person who I don't like to proceed unless I make sure that everybody is on the same page, everybody is getting it. If there is a confusion in there, and if you don't tell me, I'm not going to be able to know. And if there is a confusion and we proceed, of course, what comes after the confusion will be confusion. It's a waste of your time. So I want to make sure that we are on the same page. So please speak up if you feel like you are falling behind or if you are lost somewhere. That is your responsibility, not mine, because I really don't know how you feel, guys. Okay?
Sure, Mo. Thank you.
So now we are going to connect on X only, and we are going to store it. We are going to store it on this object. And it's done. Now let's take a look. Let's take a look. What do we have in this object? We got 1, 1, 0, 0, 0, 0. So how many 1, 1, and 0, 0 do you think we are going to get? Is the 20% of what? 41,000. 41,188. If you do the math, that is what you are going to get. And now, so this is the predicted target variable. And let's take a look on the test target. What is the test target?
Is it comparison?
No, we are not. We are not comparing right now. We're just checking them out. What is the test target?
Test target is the actual one.
How many values we are going to get? How many
20%.
records?
Same number of rows, yeah.
It's the same. And so now just take a look. So the first column is a 1. And the its prediction is 1. Is this good or bad?
It's good.
And the second one is 1. Is this good or bad?
It's good.
It's good.
The third one is 0 and is 0. Is this good or bad?
That's good. How we can get delta here?
Yes, we are going to look into it. Just hold on.
Mm-hmm.
So to compare this, to compare the actual target variable with the predicted target variable, we are going to use a concept called confusion matrix. Okay? So let's design a confusion matrix. So confusion matrix is simply comparing the actual target variable of the testing set with the predicted target variable of testing set. Okay, how many levels or how many classes we are going to have on the target variable of the 20%?
0 and 1. 1, 2.
We are going to have a 0
and 1.
And 1. Right?
Mm-hmm.
So this is called actual target variable, and this is going to be predicted target variable. For the predicted variable, how many classes we are going to predict?
Same.
0 and 1.
Yeah.
2 classes.
Okay. So so if we were to predict, let's pick only one. No, let's pick only so if we were to predict only this animal here, this student here, what would be our prediction? What would be our prediction?
0.
How do you know it's 0?
I mean, if it is based on what would we know. So
No, just
we want to
forget that we don't know anything, and we don't know this.
Oh, then 80% it would be 88% would be 0.
Let's assume we don't know that either.
Yeah, we follow the 88%, which is 0.
No, forget about that. We don't know the 88.
It would just be
frequent will come.
the probability of the.
What we predict this, it could be a 0 or a 1.
Yeah,
50-50.
50-50.
And if we were to predict this one, it could be a 0 or 1. This one, it could be a 0 or 1, right? So if it's 0 and the model predicted it as 0, it's called a true negative. If it's a 0 and the model predicted it as 1, it's called false positive. If the actual is 1 and the model predicted it as 0, it's going to be false
negative.
And if it's 1 and the model predicted as 1,
true positive.
It's going to be true positive. Okay, so which one out of these 4 here, which one they are if they happen, they are good prediction.
So true negative and true positive are good predictions.
Yes, sir. If it's a 0 and the model predicted as 0, it's good. If it was a 0 and the model predicted as 1, it's very bad. If it was a 1 and the model predicted as 0, it's very bad. If it was a 1 and the model predicted as 1, it's good. So these are a good prediction, good prediction, bad prediction, bad prediction. And let me ask you a question. Which one of these, and so which one they are, so we know which is good prediction and which is bad prediction. So false positive is very bad. And false negative, it's bad also, because it is, and the actual it's 1, and when we test the model on it, it gives us a different value. So which one you think it's very expensive to fix? If it's false positive or false negative?
False positive.
Why?
Because it was 0, but it
brother, let me give you a good example. Let's say that your wife, you just got married, and your wife feels change in her body. Okay, now you took her to her doctor, and let's say that your wife is pregnant. Your wife is pregnant. So there's 2 possibilities: either your wife is pregnant, or your wife is what we call gaining some weight, is fat. Pregnant or fat? No. So she noticed some changes in her body after at the first year of marriage. She's getting a lot of weight. And there's two possibility. Either she is sick or she is pregnant. Right? Amir?
Yeah.
Sorry, can you repeat your question again? I mean,
let's say that you got married.
Mm-hmm.
After a year of marriage, your wife feels that her body has been changing.
Mm-hmm.
She's getting a lot of weight. When she got married, she was 50 pounds and now 150. Let's assume.
Mm-hmm.
Okay, and there are two possibilities. Either she's pregnant or she's fat.
Okay, so you want me to predict which one is better, or you want me to...
Just follow with me so you can understand the process.
Sure. Okay.
Okay.
Mm-hmm.
And so let's assume that. So we went to a doctor, and so just ignore the second part. Ignore this for the moment.
Mm-hmm.
So we went to a doctor, and the doctor said, okay, she is not pregnant. So she is not pregnant, and pregnant. So if she's not pregnant, if the model predicted is not pregnant, then nothing to lose.
Mm-hmm.
But if she is not pregnant and the model predicted, no, she's pregnant, what you are going to do? Walmart, you're going to buy some diapers, you are going to buy whatever, you are going to prepare.
Right. Yeah, it's going to be more expensive to...
No. How much money you think you are going to spend in here? Just give me an estimate. $1,000?
$1,000. Yes.
Great. So what if she's what if she is actually pregnant? If the model predicts as pregnant, we are even. But what if she is pregnant and the model says no, she's not pregnant? What do you think we are going to do?
Like, we're not going to spend any money. We're not going to be...
Yes, but we are not spending no money. But you are taking her to Florida. And you are going to swim, then all of a sudden, you are 150 miles from the hospital. Then all of a sudden, she felt like there is a problem here. What are you going to do?
You may go with the miss.
No, it's going to be too late to call the ambulance. So there is a life. There is a life. She might die. May Allah forgive her, forbid that.
Right.
Or the baby might die. So which one is very expensive?
The second one. The false negative is expensive.
Yeah, losing 1,000 or losing a life.
Losing a life is expensive.
So false negative is very expensive to fix. So when you build a model, you need to build a model that does a better accuracy and with small number of false negative. Is it got clear?
Yep, makes sense.
Good. Okay, so now let's take a look into the... So now we are going to import from the scikit-learn. Now we are going to import the matrix. We are going to import the accuracy score. We are going to import the classification report and confusion matrix. What do we need to feed into confusion matrix? We need to feed two things. What are they? Confusion matrix is comparison table, cross table comparing two things.
So the target variable and predicted target variable.
Target variable of what?
Target variable of the 20%.
Yes, sir.
Data and the predicted. Yeah, the one we did this one.
Predicted also 20%. Both 20%.
Yes, sir. So let's build. So we are going to use a confusion matrix comparing the test target variable, the 20% actual target variable, with the predicted target variable of 20%, and we are going to store it on this animal called confusion matrix decision tree.
We didn't run the first part. Yep.
Yes, Here we go. Can anyone do the math? What is the 20% of 41,188? Please.
6,800, maybe.
No, that's
So 882.38.
882.
I believe that was it.
Anyone? Guys, need a true number. Or let me do it myself.
8,238.
8,288.
38.
And this is the 20% of the entire 41,188. Okay, so in our case, and how many zeros do we have on this? That is going to be do the math. 6,808 plus 490. Give me a number. Just I want to use the right number. So let's do that. So we got 6,008.88 plus 490 is going to be 7,298 and minus 8,238 is going to be 940. Okay, folks, so we got 8,238, which is a 20% of 41,188. Out of this 8,288, we got 7,298 of zeros. And we got 940 of ones. Is it clear at this point of time?
Yes.
So how many zeros that were predicted out of the 7,298?
6,800. Okay.
6808, and this is called what? True?
Negative.
Negative.
It was negative and strong negative. And how many misprediction of these zeros?
490.
490. This is called?
False negative.
No, sir.
False
No,
positive.
false positive. Yes, sorry. False positive, yes.
And how many errors the model made on the zeros?
490.
490.
490 error. So for the 940, how many misprediction? 940 of ones.
456.
456. And this is called what?
False
False
negative.
negative.
False
False negative.
False
Negative.
positive. Negative.
No, false is false.
Negative.
And how
10 false
940, how many that we have correctly predicted?
484.
484. And this is called
True positive.
true positive. How many errors made?
456.
456. So the accuracy of this model here, the accuracy is equal a true positive plus true negative divided by
Total.
20%. So if you want to calculate the accuracy is going to be what? 6,808 plus
Plus 484.
divided by what?
Total number 8,239.
No, sir. Yes, thank you. 8,238,
238.
which
38.
is what?
All positive, negative. Total record 20%.
8 plus 8 plus 490 plus 456 plus what?
484.
84. Please do the math and give me the value.
0.89.
What is it?
0.89.
0.89 or 89%. Okay, so the model that we built, the decision tree that we built on the 80% is 89% correct. Can anyone explain this 89 for me?
Yeah, so like out of 100, I will get 11 false.
So
Initially,
is this a good
initially
model?
we have 81%, I think. Yeah.
Is this a good model or bad model?
It depends on the leadership.
It doesn't solve the because the
Still
average
bad model because we expect 91, 92 theory.
So what do we need to do here? How do we know if it's bad or good model?
So we can change the parameter we used.
No, my question is, how do we determine if it's a bad or good model?
we compare
We
it with
need to
our
look
data.
We need
actual initially, like most frequent. If the most frequent is 80% and now predicted is 89.
compare it to what?
Actual data initially 80%, but
No,
80 and 20.
No, sir. Compare it to something that we did earlier.
The mean value, your
Or the
89.
baseline.
89 and
baseline model. What is baseline model?
89 and 11.
No, I know. What do we call it? Why is baseline model? It's guessing. Okay, so what is that? What is the value for a baseline model?
Was it 50-50?
No, it was 0 was 89, I think. 11 and 89 maybe.
88.
88.
So this is 89%, and this one 88%. Is it good or bad?
Still not good, but it's better than very.
It's better, but it's not good. So yes, but you guys get the point.
But Mo, I have a question. I'm still confused. This 88 or 89%, what's the probability of being 0 and 11% being 1? Why are we comparing that with the accuracy?
Can you repeat your question, please?
So this 89% was the probability of being 0, not buying the term deposit, and 11% getting the term deposit. That's the probability. Why are we comparing that with the accuracy?
No, this is the accuracy. 89 is how good the model that we trained on 80%, how good it is to determine the values of 20%. So the model,
it happened to be 89 here, but it could have been our probability from starting would have been 70% or 25%, but then this 89 would be the accuracy. In this case, it happens to be the same.
What do you mean happens to be the same? No, that means always going to be the accuracy always going to be different.
Like without this model, we have 88% chance of 0, and now we have 89% of that decisions. 1% improvement decision. That is like
right
to decide that for new person, yeah. But still, it have to go to 93%.
Yeah, I mean, but it's better. It's not good, but it's better than 89 is better than 88. Because for this one, we got 11% of making it wrong. For this one, we got 12%, and we got only one level. But it's better, but it's not. I mean, it's better, but it's not good. It's not good. So we have a lot of work to do. Okay, and that is comparing the confusion matrix. And now let's calculate calculate the, so yeah, we got that. Now let's calculate the accuracy. Is 88.52. And compared to 88.6, actually it's doing worse.
Yeah, that's what I was gonna say, because it's not 89, it's 88.5, which is worse than what we.
It's
That's
worse.
what I was gonna say.
So if it's worse, then of course this is confusion matrix. Of course we can improve that. 88.31. It's almost the same. So few things we gotta do is change any of these parameters. But before we do that, let's take a look into the tree. Let's take a look into the important. This decision tree, of course, it does use all the features. It does use all the features to build the model, to learn the parameters, to learn the patterns. It does use all these features here. But some of these features here actually might not be were not important for a decision tree to make a decision. So to determine which features were used, we are going to import something called feature importance. It's called feature importance. It's simply a parameter that was designed for all decision tree for decision tree models. So we are going to import these features. Actually, it's called here decision tree. It's called decision.
It was DTM.
It was DTM, right? DTM.
Yeah, thank you, sir. Yeah, thank you. DTM. So look into this. So it does use age, duration, and as a matter of fact, because I changed these parameters. Let's go back to the original one. There we go. So because we used the defaulted model method, that's what happens. Okay, so now I'm going to show you. Before I talk about the importance, let's take a look into the decision tree. And I will explain that. Yeah, it's a huge, very huge. That's why we are getting a very bad accuracy is because we literally run all the way to the end. It simply learns the position. It learns how to make a guess. That's all what it does. That's why we got a very bad, the same accuracy. It simply learns the zeros and learns the ones. And that's what is happening here. So later on, and I'm gonna simply it is gonna split, it's gonna split on all the features and compare the accuracies, then split again, and the second split, third split, all the way to the end, unless we don't have any more data set, any more features, any more records. So it is gonna take a while. And if you let it run all the way to the end using all the features, all what it does is remembering the zeros and the ones. In other words, it's simply learning to guess. And of course, it's going to guess at the same guessing value, that is 88%. That's why we are not going to get any better. So we want the decision tree to run, but we don't want it to run all the way to the end. If we let it run all the way to the end, it is going to memorize the data. And when it does memorize the data, it is going to guess. Let's take a look. Hopefully it's done. Yeah, the graph is too large, and so it's too large. Okay, it's not going to work. And I'm going to stop it here.
Brother Mo, so what is the last, how is that different from the decision tree again?
Which one?
Like this code, how is this code different from the decision tree that we just did above?
Yeah, just hold on in your question, sir. Hold on that. Here we go. So now, yeah, I'll answer your question. So now let's put some control in there. So we are going to do here. We are going to do let's do a max state 4. Okay. Then we are going to train. We just build a model and we set the control in there. We do not want to run all the way to the end. And now we fit it in 80% X and Y. We tested on 20%. We calculated the confusion matrix. Now it's different. And now we calculate the accuracy. Is what? Is it good or bad?
Definitely better. Definitely better than.
Why? Because now it starts learning patterns, not remembering the data. And now let's go all the way and see the codes, run this, and I'll explain the codes later. Here we go. This is the decision tree. And I asked it to save it. Let's take a look into, and okay, it's going to be on a desktop. BBDS. Actually, let me stop. Here we go. So it splits on number of employed, and the value was less than 55,087. Is it false or true? And keep splitting. And now we got pure class 1, class 0, class 1, class 0, 1. So in other words, now we start with number employed, then the duration, then we split again on duration, we split again on duration, and we got the probability of zeros and 1. And this is 1, 2, 3, and 4. So we got one split, a second split, third split. Actually, this is one split. Sorry, guys.
Top one would be first.
Yes, sir. Yes. Thank you. So this is the first split, a second split, a third split, and the fourth split. And that is what we told it to do. We told it to stop.
Depth 4.
Yes, sir. Yeah, that is what we told it to do here. Where is it? Okay, and now let's take a look. So we know it's 91% accurate. It's better than 88, but it's of course we can improve it. And now let's take a look on the importance. Which features that were used to contribute to the 91%? So we got a lot of zeros. They even did not use them. So age was not used. No, duration, campaign, paydays. So what do you think we should do with these features here?
Remove them, maybe?
Yeah, we need to remove anything that was not used to train the model. Let's take a look into the importance. And I believe I need to change these to DTM. So look into this. So everything else, it was there, but it did not have any importance. No importance. So we need to eliminate these features. And this is what I did here. Again, we need to change that ATM. Now this is in descending ascending order. So the most important feature to determine if Idris will purchase term deposit or won't is duration, followed by number of employed, followed by the conf index, pay days, comprise, and job unknown. The remaining is we are going to remove them, and this is what I did here. I created a list. It's called to drop, and I dropped them. So when we drop them, then now what do we have in the what do we have so when we drop them, we overrided the existing data with the new features. So how many features do we have left?
5.
And how many features that we started with?
41, I think.
51.
51.
So the model only, out of the 51, the model only uses 5 features to predict the value of target variable on the test. So what do we need to do? We need to remove all the features that will never been used. And now what do you think we should do? After we removed the features, what do you think we should do?
I think we should do again the train and then
yes, but where do we need to start? Where do we need to start?
Like
decision tree.
No.
You can create a new, you can store them in a new, then.
So we need to.
We should do with the prediction.
We need to identify X and Y again.
Yeah.
Sure.
Okay? We need to identify X and Y. So now, before we got 50 X's and 1 target variable. And now how many X's that we have?
5.
No.
Oh, 4, because we don't count the target variable.
Yes, sir. So actually we have 5 features. Out of these 5 features, how many X's that we have?
4.
And how many Y is
4.
1. So now we need to identify X and Y again. Okay. And after that, we need to split again, because now we split now on the 5 features, not 51. And what do you think is going to happen with the guessing? Is going to change? Is going to improve or decrease or stay the same?
Should improve. Should improve.
If no use, then it's same, remain same.
Same. It's not going to change. Okay, it's going to be the same. It's not going to change. And now we are going to build a model. We are going to build the decision tree. So we are going to import the decision tree. We are going to initiate the decision tree with the entropy and max dit 4. Then we are going to train the decision tree on 80%. Okay. We are going to feed the decision tree the train on the using predict on the 20%. We are going to compare the decision tree. We are going to compare the predicted target variable of the 20% to the actual target variable. And what do you think will happen with the accuracy that we already learned? Is it going to go up or go down?
Same.
Should go up, maybe. I don't know.
No, you cannot guess the product. Just think about it.
I think it should be same because the rest of feature was not using. It was
Yes,
0,
sir.
0. So
yes, sir. Thank you for thinking like data scientist. It's going to be the same. Why is that? Because simply the model that we built on 2081 only uses you only uses these features here. This four, no, 1, 2, 3, 4, 5. See, I mean, actually, I removed the 2. So only uses a few features. Either you keep this or you add them. It won't make any change. So it's better. Why do you think we should not keep them?
To improve the time, processing time.
Yes, sir. If you leave them, of course, it's going to take a lot of time to do them, but even though they are not contributing to the accuracy of the model. If you remove them, you are going to speed up the training. That is the only difference. Okay, let's take a look. Now we build the model, and now, we build the model again, confusion matrix, and now let's do the accuracy is 9131. And now let's take a look into the important, only these features. Now 1, 2, 3, 4, 5. Now let's compare them. And here we go. So this is all the features that we used to build the model. And after that, we are going to look into the actual decision tree. Beautiful. It's beautiful. That's it.
Yeah, no, it's very, very fast.
Yeah, very fast, and it's good. So now we got a model for 81%, or almost 92% accurate. So this value here simply means instead of guessing that Idris will be a 0 for 88% and 11%, and now we got 92%. He's going to be a 0, and 8% is going to be a 1. Always we are going to have a problem there, but this is better. It's better. Okay, and we could improve this a little bit by simply playing around the parameters. So let's say that if you were to do add comma and purity, and we add 1, we just play around the numbers, but this is not the right way to do it. Compare the confusion matrix, and accuracy is 88. Actually, it dropped. So this parameter here is not the right value, and we have to try this. We have to try 0.1. Let's see what's going to happen. It's still 88.5. So we better leave it as 0 or remove it. And so we play with these numbers, and manually or systematically. Unfortunately, it's not part of the program. Otherwise, I'm going to show you how you could do it systematically. There are many methods. One of them is called grid search. The other one is called random search. There are many methods that you could use to improve the quality of this model. Okay, folks. So any question, concerns about decision tree?
So if you
I
had
have
changed,
a question. Sorry, brother. Yeah, when we see the tree, so we see NR implied from the first one, from the start and splitter. But when we see the importance, so it is duration. So it confused me why.
The importance is not how it splits. So the importance does not mean you have a better entropy.
Okay.
So the importance of making a decision is different than how entropy, the value of the entropy are going to have. Yes, that is a valid question.
Thank you.
You're welcome.
so Brother Mo, we could have run this now by just changing entropy to Gini, and would it
could do it.
run the same thing?
Let's do that. Good thinking. Let's do Jenny and see what's going to happen.
Or can we just remove it? It will be the default.
I mean, if you remove it, it's gonna go with the Jenny. If you were to remove it. It's better. 32. It's it's better. But before we do that, let's try the entire data set. Don't let's try the entire data set. So we are going to import data set here, the entire data set, and we are going to remove and now we are going to identify X and Y. Okay, split, and we are going to go straight to decision tree. Is 114 millisecond. We are going to compute the confusion matrix, and we are going to compute the accuracy. It's 91.33. It's going to be the same. Okay, and now let's go back and re-identify X and Y. Identify X and Y one more time. It's going to be here. Yeah, I think Gini index is a little better than the entropy. The entropy is 91.31%, and the entropy is 91.31. No, the Gini is 91.32. So every small fraction could make a huge difference in prediction. Okay? So tomorrow we are going to actually look into how the decision tree make such decision. That's what we are going to do tomorrow, and that is going to be the end of the program. But at least I really hope from the bottom of my heart that you guys are going home with a clear understanding of the big picture of data science project A to B or end to end.
No, this is a very good way of teaching. I think we are getting the good concept. Oh, I really appreciate.
No problem, sir.
Thanks for the guidance.
Thank you so much, Brother Moya. It is wonderful. Yeah.
I hope you guys, if you have a chance, you really want to learn more, we have a program starting in July 31st. It's 7 months. It's 8 months.
So when is the registration is starting?
Yes, yeah, I'm going to share. We are still working on that because we are going to do some improvement based on the feedback. I'm going to share the feedback with you guys. We recorded them yesterday. And, honestly, you really don't need to take the program to be a data scientist. I really don't care about the money. I care about you learning data science. So you really don't need to take our program to be a data scientist. You can learn data science on your own. You can, if you have money, you have time, please invest. You could use apply on the postgraduate degrees, master degrees, bachelor's. Please do something. You really need to start your journey, regardless of where to start or with whom to start it. Otherwise, you are going to end up regretting it later. It is the right time to invest in learning data science. But if you decide to learn data science with us, it is definitely going to be a different story. We are going to treat you with confidence, trust, and honestly, we'll do our best to make sure that you are getting the values out of whatever you'll be investing. I know the program is very long, but it is a high quality program. You are not going to regret investing in our program, but that does not mean I'm selling the program to you. I really don't care. The most important to me is to see most of you in the field, transitioning in data science, either through us or through many other programs available on site online. If you decide to learn data science on your own, please reach out to me. I will be more than happy to assist you in that direction. I might not be able to coach you, but I will give you some directions, and it's on your own risk. Okay, folks, that's it for today. I'll talk to you tomorrow, and tomorrow is going to be our last day, unfortunately, because I'll be traveling overseas. So I want to make sure that I'm done with this training. The program was actually 10 weeks, once a week. But I know it's not going to be enough. That's why we decided to make it twice a week, and for the length of 10 weeks. But now it's 8 weeks, but we are done with the most part of the project. And whatever you learn from here, it could be your jump start to think seriously about data science. And as you can see, it is a piece of cake. All what you need is a heart, passions, patience, dedication, and commitment. You really, age is not a problem, background is not a problem. You can still make the living through data science if you were to invest money-wise, time-wise, and effort-wise. And you got to do it before you hear the music. You are going to hear the music a year from now or 2 years from now. All the companies now, they are switching to a data-driven decision management things. If we don't have, and they are moving into automation. So automation will steal our jobs. Whatever you can do today, I can design a model tomorrow to do it in 5 seconds and cheap. So learn data science, otherwise you are going to be a victim. I promise you are going to be a victim, either today or tomorrow, sooner or later. So just learn data science to avoid being a victim, number one. Number two, to prepare for any transitions and for this to secure your spot in the market. That is my two advices to all you brothers and sisters, especially those who are thinking seriously about their future. Their future is very dark with the machine learning, artificial intelligence, automation. We really don't know where we are headed. We don't know what's going to happen 3 years from now. We really don't. But if I were to hire you, if I have an opportunity to design a model or hiring you, I would design a model, because it's one time, boom, I'm done. But you're going to be very expensive, monitoring your progress, eye check, and there's a lot of headaches. That is the risk. There is a risk of us losing the job in the future because of automation and because of machine learning and artificial intelligence in general. Okay, that's it for today. I'll see you guys tomorrow. Until then, you guys have a great weekend, and bye, everybody.
Thank you.
Thank you very much.
You are welcome.
Thank you, brother.
Thank you.